sample problem involving first-order linear differential equations. So here's a sample problem. A woman was drugged in a bar one night. She was found a few minutes later by police. Among the pieces of evidence in the crime scene was an empty 20 mg sachet that was tested positive for drug residue. A drug test conducted at 1 a.m. indicated that she had 10 mg of drug in her bloodstream. Another test was conducted an hour later after the initial drug test, and it indicated that she only had 5 mg of drug left. Assuming that the drug mixed completely with the blood in the instant she took it, and she did not intake any fluids in between the time she was drugged and throughout the drug tests, and that the amount of drug degrades at a rate proportional to the amount present, when was the victim drugged? So for the solution, we can ask our friend Christian.
Okay, so good morning. For the solution, first we have to get for the given. So there are two factors involved in the problem. First is the amount of drug, and second is the time. So we have to set variables for these factors. First, we set x for the amount of drugs in milligrams and t for the time in hours. So it is also given in the problem that an initial drug test was conducted and there was 10 milligrams remaining in the blood of the victim. So we set t is equal to 0 and x is equal to 10 milligrams. And it is also said in the problem that after 1 hour another drug test was conducted and there was 5 milligrams remaining in the blood of the victim. So in the problem we were asked to get when was the victim drugged. So we set x is equal to 20 because the sachet contains 20 milligrams, and we assume that all of those drug was ingested by the victim. So we have to get the time. So for the solution, it is said in the problem that the rate of degradation is proportional to the amount remaining. So dx is the amount of drug and dt is the amount of time, or rate of time, sorry. So this is the rate of degradation. So from here, we have to integrate this using separation of variables. X is moved here and dt is moved there. So we go through this process, integration, and we will get this resulting equation. From here, we have to use the initial conditions. First, we have to use this condition in this equation. So just substitute the value of t and x. So t is equal to 0 and x is equal to 10 milligrams. So from there, we are going to get the value of C1, which is 10 milligrams. From there, we will have a new equation, which is this. We just to substitute C1 in this equation. So we have this new equation. So from here, we have to use the second condition, which is T1, t is equal to 1 and x is equal to 5 milligrams. So we just have to substitute T1 here, x equal to 5 milligrams here. So go through this algebra and we will get the value of k. From here, we are going to have a new equation again, and we will have this equation. Just have to substitute k and substitute value of C1. So here, from here we can get the value of t, which is the question asked to us. So we just have to substitute the value of x so that we can get the unknown variable, which is t. So just have to substitute 20 milligrams and do all the algebra from here, here, and we will get the answer, which is t is equal to -1. This means that the victim was drugged approximately 1 hour before the initial drug test, or at around 12 midnight. So that's all. I hope you understand.